Hello, student. Welcome to the Signal and System course. My name is Gafalla Awi, that I will be your instructor in this course. I am really excited to teach this class for the Chinese student, and I hope you will spend enjoyable and beneficial time with me during this course. Uh, so I want to start for this lecture specifically, since this one is the first lectures. I want to start to introduce myself in personal and professional informations, and then we go together to the course policy and syllabus. And after that, I will provide you the overall what you expected in this course, and what kind of the applications in real life application that your interact daily, and it has a related with the information that we will provided in this course. So the first part here, introductory for myself. My name is Kafalla Awidat. I'm originally from Libya. I live in United States of America, in Washington State, in Tacoma area. I have 4 kids, range between 13 and 10. And regarding for professional career or professional informations, I have a PhD degree in electrical and computer engineering from Western Michigan University. I have been a professor at Pacific Lutheran University since 2016. I taught many courses in computer science and electrical engineering as well. As far as the research area, I have been in the research more than 10 years. My area of expertise, signal and image processing, and I have many publications related with the cancer classifications, face recognitions, and my recent area or active area, it is autonomous vehicle or self-driving vehicles. And I am focusing about the feature detections and how to accurately and precisely identify the object around the vehicles to end up with the accurate decisions and safe driving car. This is my informations. Now let's start or let's walk together through the syllabus and see what the policy and the thing and how you grade your course. So let's go bring my syllabus in the screen. Okay, so here's my syllabus. Before we start to explain my syllabus and philosophy in this course, I want to let you know this syllabus will be available for every one of you in the class website, and kindly go and read it and go through it. And if you have any question, any comment, feel free to bring it next class or email me about it. So let's go do it very quickly. The first part here, just general information about my office and my office hour and my email. And I want to mention about my office hour, or I call it sometimes student hours. I know I listed 2 time frame that I will be available in that time, but I know, guys, many of you, they are busy and they are not available in that particular time. Kindly, guys, this is office hour. It is officially, you will find me there. But what I want you to keep it in your mind, I am totally available to provide you the help, guys. You need to ask for a help in any other way. So you can talk to me after the class. You can email me if you need some help. So we can find the time to meet together. Another thing, so even if you cannot stop to my office, so we can set a virtual meeting through the Zoom. So just email me, I can send you the link, and then we can discuss and others, and I'll provide you the help regarding for the issue or a question you may have. Just, guys, you need to ask for help. I am here to help, guys. Just make sure about that. The second part here, we mentioned about the signal and system textbook that I will use as a main resource for all the material I will represent. I am kindly ask everyone he has his own copy. That copy, it could be hard copy or soft copy or Chinese versions, whatever you think it is accessible and available, you can get it and you get the beneficial from it. So it's good to have a textbook with you. Job descriptions and job objective. Well, I will talk about this one in a few common slides. I add here is the course outlines where I listed all the sections and sections I will cover it from the textbook. And related with those outlines, guys, I want to make sure about this one. This is one just the guidelines, but it could be changed or adapted depending about the course progress. What I want to make sure that, guys, I don't focus basically just to finish all the materials. I'm just focus how much you understand, guys. So basically, I am considering the quality on the quantity. So in another word, if any certain time during the course and you stuck at a certain concept and you think we need more time to in this particular topic, we need more examples, or we need more time to understand and absorb that materials, I definitely fine with this. I just to provide you some materials you can understand. But I don't worry so much. I have to finish all the material. That's something you keep it in your mind. Regarding for the grade, I have many categories. I graded your grade, how you get your grade. But generally speaking, if you did your job, you attended your class, did your homework, you will be in the good position. But generally, how to instruct my classes, usually we have a class exercise when we cover the topic and they give you a certain problem or certain example and you want to solve it. Usually I use the uh, uh, group the student in a certain number of the group and discuss that particular example and then provide me the solution for this one and discuss that one. So you get this part. And the second part, individual part, which you have a weekly assignment that you need to do it. And we have a quiz, and the quiz basically based on the assignment that you already submitted. And we have 3 exams, 2 midterm and 1 final exam. And I provide you help with this one too. Any midterm or final exam, we set a meeting or I set you the guidelines for every single exam. That you can see what you expected to see in the exam and what the material you will see. So you're not surprised in the exam at all. And depending about your request, maybe even we set a time of the lectures just to discuss the topic that you will see it in the exam. If you have any questions, you can bring it and we can address that one. So I provide you the help with this one. And really my focus is to come in the exam. You don't have to very stressful and very freaked out. Really. That's the main thing. So you find more other materials in the syllabus. You can look at it, and if you have any questions, just let me know. Let me stop in this part here and go back for the slide. So now the first thing here, we give you the overview. So the first of the starting point is what we mean on what the R signal and system in the first place, the title of our course. So I give you this diagram here when you mentioned about we have a system and we have the input and output signal really. So you can see. So if you ask any one of you what we mean by the signals, you signal input and signal output, and you said me, okay, what do you think? What I can simply define the signal. That is a piece of information is entered to I feed it to my systems. What my output signal, it is whatever it change it's happened in my signal to the output and provide me with my output signal. So what the system itself. So right now, if you look at the relation between my input signal and output signals, so one can say, okay, I see the signal is not going to change except the magnitude. So my signal is, or my system is magnify the signal. So my output signal changed because of the system. So basically the entire course here, we're dealing with those 3 things really. Signal, input and output signal, and the system. And just we're gonna expand that knowledge where we study the signal itself and then study the system itself. Then we study both of them together as a one system. That's basically what we're gonna do. But before we go this one, so we need more, let's break it down to see more details, what we mean by signal, what we mean by system. A signal here, it is a piece of information, as I mentioned, but if you wanna specific definitions, you can say any quantity can be measured, or any measured quantity, we can consider it as a signal. Many examples in our real life, radio signal, we hear the radio channels, cable TV, when you listen to music and when you see the voltage or current circuit, voltage or current source and stock prices, all this one considered as signals. Okay, so is this one signal definitely that they are not in the same categories or they are not in the same representations. What we mean by that, we can look in deep what the signal are. So one thing is I can identify or classify my signals to two main categories. The first category is continuous time domain. It is obvious from the continuous mean my signal change over the time and it has a value for any single moment of time. It is continuous. There is no such discrete value. So they have a continuously. So an example for this one here is the FM signals, or even we have AC voltage or current that they are continuous with the time. Another example here is the audio or even my speech right now, when I am speaking right now, this is considered as a continuous signal. It is continuous with the time rate. Okay, that's the example for a continuous time signal. Now, the second part or second category is discrete time signals. We call discrete time signals, and basically it's mean it is we have a signal and it can be measured at a time point, not the continuous. An example for that, if I ask you to measure the temperature in 24 hours, so here is your time or your hour here, and here you measure a couple of the points, the temperature in every single hour. So you end up with discrete signal, and our time here or x-axis is time domain. Okay, but this one is not the case. Even we state it is discrete time domain, but this one is not all the time case. An example for this one, if I am dealing with the gray images, what the information is, it is not functioning with the time. If you look at this one, it's flexing with the pixels, and that pixels, it has intensity and it has allocations, X and Y, or M and N. So in this case, even I call it the system is discrete time, but it can be represented not in the time domain. So what we're gonna dealing with this course here, I have two represented. Here represent a continuous signals, and in discrete signals, we represent it as the N, as the identified to the discrete signals. Okay. Another thing that we're gonna spend a couple of days or couple of lectures related to the signal domains, how to represent signal domain. If there's any question, guys, here I listed here Fourier transform. Have you heard with the other transforms or under the transformations method? Okay, and have any question, any answer with this one? Yes, Laplace transform, continuous Fourier transform, Z transforms. So we have plenty of transformations. And the transformation is when just look at your information on your signal in different domain. That's what I mean by transformations. So we have many transformations. Why we need these transformations? That's why this question we're gonna address it in this course. And not only that, so we know before we start any transformations, why reason we need this transformation. In addition, we're gonna see how to make the transformations between all, for example, I can represent my signal time domain and Fourier transformer and Laplace transformers. I know how I can transfer from one domain to the other domains. That transformation for the signals, we're gonna spend plenty of time in this course just to understand that transformation. In this example here, just to give you the beneficial for the Fourier transform, or the frequency domain transform from the time domain. So here is an example. We have three signals, sine wave signals, and if you add them together, you end up with the fourth cosine signal. It is continuous. It's infinity to infinity. But if you give you this formula and you indicated that, and this formula, it's basically just addition of the three signals, and every signal, it has a certain amplitude and certain frequency. So I have basically 6 characteristics or 6 parameters can be identified this signal. Why we select those 6? Because that's where my information located. Okay, so this is another thing. So I can represent my continuous signal with the minus infinity to infinity domain to just 2 components, where it is located and how much amplitude is. So in that case, I'm able to get for simple analysis, not only that, and even for the design. We're not dealing with this course with the design so much, but that's the one thing you can use it when you make transformation. So in this course, you will be aware what kind of transformations and how we deal it and what the characteristic and advantage in each one of them. Okay. Now move for the second part, which is talking about the systems. The systems in basic definition, just the relation between the input and output. That's in the simple definition. So we give you multiple examples here: radio, receiver, audio amplifier, modem. All this one here as a part of the system, they can find the relation between input and output. For example, the microphone, you have the input signals, and you magnify your signal and to put it in the good amplitude. So that's the systems. Yeah. So here's the naive example. So everyone familiar with the electrical circuit, I can look at the circuit as a system. We have the input signal, a voltage source, and we are looking to measure the voltage source across the capacitors. We consider this one as our as a system, and we have the input, and we're looking for the output and the system. And this one we can just thinking as a filter scheme. Okay. So that's the first part really in this mail that we're gonna cover in this class. And now where we can see all those topics in real life. That's what we mentioned about the application of signal and system. In fact, we can see a lot of the application real life around us. But I just pick up some applications, so very famous and very good application. For example, here communication system, we have a transmitted and a receiver, and we have a channel in between. So here in the satellite, so we have a certain information we need to send, and then on the other side, we need to receive that signal and recover that signal to be heard. So all the steps transmitted and the channel and the receiver to consider is a system. Another famous application, artificial intelligence. Everyone now aware of what to mean by artificial intelligence. And here is in this example, we have the input is the image, and the output will be a label of that image. We call it the classifications here. And all those steps in between, they are considered as the system. So here the signal and the systems. And the second one, capture generations. When you're given the image and your output or your artificial intelligence algorithm provide you the label for this image. And don't have to be scared, guys. So we're not gonna dealing with this kind of the complicated system in this class. I just bring those examples to be aware what kind of the variety of the application you can see it for signal and systems. Any questions so far? Let me know if you have any questions, please. Now, what you are learning in the signal and systems. I can categorize that 3 categories that you're gonna learn in this course. And in the first part, you consider as a foundations, where we can consider signal itself and make all the analysis and all the tools and all those transformation for the signals. That's the first part. The second part, we're gonna do the same thing for the systems, what the characteristic for the systems. And then the third part, how we're dealing with the system, with the entire system together, with the signal and system together in one signal. We're gonna consider this one with all those transformation on all the relation between input and output. And we did a lot of the convolutions, how to find the relation, even if you have a system and you have the input, you need to find your output, or you have the input and output, how to find your system's function. So we gain all this kind of stuff. And the second two part, just this kind of thing we're gonna apply for the continuous signals, and the third part for the discrete. So they have a different aspect, but they have the same criteria in how to make those kind of analysis for the entire system. That's what we expected to see in this course. As far as the main object, there is many learning lessons. You will see it in this course. This course generally it's not easy, but you are learning a lot of things. The first thing, you be familiar what we mean by signal and system in the first place. Be familiar with the how to make the relation between input and output by introduce the convolution in the time domain or frequency domain. Your skills or the problem skills you will be gained, and you will be have a lot of tools to add for your skills for analysis. And the last part, we're gonna introduce when we're talking about the discrete time signal, how to identify the stability of your system, how you identify your system is stable or unstable. So it's stuff like that. I think there is the many lessons we'll be learning from this course. As a conclusions, really, guys, so I hope this course will be beneficial for every one of you. And this course will be provide a lot of the variety of the analysis and stuff. And my mission is here to simplify that concept by provide you the concept and supported by real application and real example to solve, and just to be aware for all this kind of topic. But we have a lot of things to cover, and your textbook it is provide you a more support, and if you need to understand more information regarding for any topic. Thank you so much for listening, and really excited to see you next time, guys. Thank you.